So let's start with the general introduction. All of you have some background about either automata or Petri nets, about their structure in terms of graphs of states and transitions, about their behavior, and you know about some analysis techniques. Well, it's nice to use these models, these formalisms to make models of systems and to analyze concurrent systems, but sometimes you need to have a bit more in order to tune the model, or you need parameterizing the model. So how can we do that? Why do we use parameters? Here are a few examples of cases where you are interested in parameters. So maybe you have several copies of a same process or a same component in your system, and you want to do some dimensioning. So for example, if you have sensors in a wireless sensor network, maybe you want to have 10 sensors, but there would be another case where you have 100 sensors. And they behave similarly. So you want to do one copy and have several instances of the same model. But maybe a priori you don't know how many you will have. So you want to use a parameter to know, to say, well, I have a certain amount of processes, of sensors or whatever. Another possibility is that you have multiple a priori possible actions. So you're designing your system and you think, oh, that action might be useful. I will plan to use it. So I model several possibilities, several design choices, but maybe they are not compatible with each other. So when you do the analysis, you see that one is never used, or if you have two together, it doesn't work properly. So you want to design your system with all possibilities and then choose which one you will actually use. Another case where parameters are useful is when you have several hardware components and that have different characteristics, and you want to make choices as well. So for example, you have different response time for electronic components, and you want to know how it behaves with some response time or with another response time, and decide whether you use one component or the other. Maybe they're not the same price when you implement the system in reality afterwards, and you want to be aware of the properties of your system depending on which choice you do. Therefore, you can see that with these three cases, we have different possibilities for parameters. So in the first case, it would be instances numbering. In the second, it would be enabling or disabling actions in a system. And in the third, you could have time or maybe probabilities. Okay, so in usual modeling languages such as PetriNet, Automata, or the usual extensions that you know about, you have some things to address that, but it's generally not sufficient. So for example, numbering instances of processes is possible with colored PetriNets, but a priori this number is fixed. So you would say I have a process that looks like this, and I have a way to say this is that instance or that instance. But you would say a priori I have 10 copies of my processes or 100 copies, and you analyze the system with that. There is no specific handling of uncontrollable actions, so you can say, well, I have many actions, but handling that these actions can be controlled and the other ones cannot be controlled is not, in general, not embedded in the formalisms. And for timing, for example, what is included in timed automata or a time Petrinet is also fixed. So you can say, well, I will find a transition or some action will happen within that time frame, but the time frame is to be fixed at the beginning. What we'll be interested in here is not to fix this time frame, but deduce what it should be. So the problems of interest here in parametric verification will be to model the path of interest with respect to parameters, to find some constraints on these parameters that guarantee the desired properties. So to say, well, if I want this property, the parameter must have satisfied this formula, for example. And another interesting thing is to find all parameter values that guarantees these properties. So these are problems we will address today. At this stage, well, you have an idea on parametric modeling issues, instances, uncontrollable or controllable actions, time or probability constraints, and some problems to address. So now we'll start with timing parameters in the next sequence.